This is page 2 of the Chapter 2 review. The first problem says to find the vertex and line of symmetry of the parabola f of x equals blah 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 blah. So, there's a lot of ways to do this. I could graph the parabola, I could factor it, I could do a ton of things, but I'm going to take the easy way out. Well, I know that the vertex is going to be at negative b over 2a. And since this is already in standard form with a, b, and c, this will be equal to negative 10, which is 10, over 2 times a, which is 10. Awesome, that's just 1. So this is the x-coordinate of the vertex. Let's figure out what the y-coordinate is. Well, to figure that out, I can find f of 1. Well, that'll be 5 times 1 squared minus 10 times 1 plus 20, which is just 5 minus 10 plus 20. Or, in other words, 15. So, the vertex is at the point 1, 15. Now, if I want to figure out the line of symmetry, this is going to be a parabola with a vertex at 115. The line of symmetry is just going to be right through that. So, a vertical line at 1, we write that as x equals 1. Line O symmetry. That's, I think, the easiest way to go about this, but there's other ways as well, and you're welcome to do them. Let's go on to problem number 4. Write a quadratic function with zeros at negative 2, 5, and a y-intercept of 5. Well, since this gives us the zeros, I think that the best form to write this in would be factored form. So, we write x plus 2, because one of the zeros is at negative 2, and x minus 5, because one of the zeros is at 5. So our function will be f of x equals x plus 2 times x minus 5. But then the question is, does that have the right y-intercept? And the answer right now is probably not, because we need to stretch this function to have a y-intercept at 5. So we'll put some sort of multiple on the outside, so it'll stretch out the whole function. Now, if the y-intercept's at 5, that's going to be the point, well, 0, 5. So let's plug that point in. X is going to be 0, y is going to be 5, wherein we end up with 5 equals a times 0 plus 2 times 0 minus 5. Or 5 equals a times 2 times negative 5. 5 equals negative 10a. Or a equals 5 over negative 10, negative 1/2. In that case, our final function is going to end up being f of x equals negative 1/2 times x plus 2 times x minus 5. And we are done. This is our quadratic with the right zeros and going through the point 0,5, or having a y-intercept of 5. Let's look at one more problem. Solve this quadratic. This problem doesn't look like something I can solve very easily, but maybe if I can figure out a convenient thing to make u equal to, then I can set this up to something that looks a little bit more familiar. So I notice x to the 1/3. That x to the 1/3 and x to the 2/3, well, that is just sort of first power and squared. So I'll make u equal x to the 1/3. So that way I'm left with, well, the x is going to be, in other words, x to the 3/3, which is u cubed. 3 of those x to the 1/3. Plus 7 x to the 2/3 is going to be u squared. plus 10 x to the 1/3 is going to be u. This all is equal to 0. At this point I can factor out a u, so I'm left with u squared plus 7u plus 10 equals 0, and I can probably factor that to get u times u plus 5 u plus 2 equals 0. At this point I can see that I've got that u equals 0, u could be negative 5, or u could be negative 2. In other words, this gives me x to the 1/3 equals 0, x to the 1/3 equals 5, negative 5, or x to the 1/3 equals negative 2. In order to figure out what x is and not what x to the 1/3 is, I'm just going to have to cube everything. If x to the 1/3 is 0, then in that case x equals 0. If x to the 1/3 is 5, if I cube it all, I end up with x equals negative 125. And if x to the 1/3 is negative 2, if I cube all of that again, I end up with x equals negative 8. These are my 3 possibilities. This is, I think, the solutions to this problem. Hope you found this helpful, and that is all.